Good morning, Grid Connections listeners. Today we have Ed Bernardon, the host of the Future Cars podcast. Along with being a former VP at Siemens, he currently runs his own consultancy for Motorsport technologies. Ed has a remarkable background, spanning from the world of high-tech manufacturing to the cutting edge of motorsports. He's here to share his insights in the world of motorsports, along with how the space is pushing electrification in many forms. Throughout this episode, we'll discuss the intersection of electric vehicle technology and motorsports, the challenges of scaling sustainable fuels, and how motorsports are embracing electrification to stay relevant to a new generation of fans. If you're curious about the future of racing, battery innovation, or the potential of carbon-neutral fuels, this episode is a must-listen. As always, we'd love for you to share this episode with at least one friend or colleague who'd enjoy it too. And if you're enjoying our podcast, please take a moment to leave a positive review on our podcast page. Your support helps us bring more exciting conversations like this to you. With that, enjoy.
Yeah, Chase, great to be with you. And maybe I'll give you a little bit of my background, show how this world of technology and motorsports has sort of come together here. But just going way back, my parents were both from Italy. They actually immigrated to the United States after the war, and they settled in Indianapolis, which is the home of the Indianapolis 500. So there were no baseball or basketball, football fans in my family. It was all about racing because Mario Andretti happened to come from the same part of Italy. So, and being in Indianapolis, of course, especially in the month of May, racing is what that city's all about. So that was really how sort of I got interested in racing in the first place. When I got out of from Purdue University, I went into the automotive industry, worked at GM. And then now my wife, then my girlfriend, convinced me to go to grad school. I sort of didn't really want to because I really enjoyed making all that money and having fun going to bars and all that kind of thing. But anyways, I ended up coming to Boston, going to grad school. And my first job out of grad school, because I had mainly focused on robotics, was making robots to make clothes. So this was with the Draper Laboratory. They're known for their guidance systems and missiles and things like that. They decided to get into the commercial business, and somehow they picked making robots to make clothes. Yeah, exactly. So we were really some of the first to work in that area, and we developed a lot of expertise for handling flexible fabrics with robots. And due to the fact that Draper Laboratory has so many connections in the military and then defense industry, we said, hey, we could apply technology for manipulating flexible fabrics to carbon fiber. And because it's pretty much carbon fiber starts off in the fabric. And that's what we did. And we started making machines that actually ended up going into factories for forming parts for helicopters, Sikorsky, United Technologies, those kinds of companies, as well as at the time, Ford Motor Company was also looking at doing composites. So we went from making machines for making T-shirts and blue jeans, parts for men's suits, using almost the exact same technology for making airplanes. And the one thing that came out of that was this little piece of software we designed that we needed to figure out when you shape a piece of fabric into 3 dimensions or a piece of carbon fiber, first you have to cut it out in 2 dimensions. And since carbon fiber is so expensive, knowing the shape to cut out in 2 dimensions so it fits perfectly in 3 was a hard thing to do. And we couldn't, since we were doing a lot of experiments, we figured there was software out there to do that. There wasn't. We wrote it. And it turns out people were more interested in that software than they were in the machines we were building. So myself and 3 other people started a company. And initially, it was really software that would predict the 2D shape for any 3D shape you wanted to lay up for composites. And we built that business from about 4 people to about 80 or so over a 10-year period. And our main customers, our biggest customers were in aerospace. Anything that had to be fast, light, and very expensive, military helicopter, fighter plane, they're pretty much made out of composites. However, Formula One, they're pretty much, certainly the car body itself, suspension components, that type of thing, are all made out of carbon fiber as well. And although they were a small part of our business, they always got our software first, because racing has this knack for taking anything you think is going to work perfectly, and they're able to show you every fault, and they do it fast. It's not like an airplane. A new one is designed every 5 years or so. in Formula One, you learn something in one race and you're designing a new composite component for 2 weeks down the road. So as part of that, we got to really know the Formula One teams. And over that period of time, a lot of them now are our good friends. And so we were acquired by Siemens. And once at Siemens, and this is a typical transition, I think, from a startup of 80 people to a corporation with 350,000 people. Continue to do the composites work, but it actually, it was a little bit easier. Let's just say I had some spare time. And in that spare time, we used it to develop business. And as always, I said, this is my chance to really get back into motorsports with the technology power that Siemens had. And so that's pretty much what I did. And just as an example of some of the projects, the first one was with the FIA, which is the sanctioning body for Formula One rally and all those. And what we did was we took autonomous car sensors, LiDAR, radar, cameras, and we mounted them inside rally cars. And rally cars are these, they don't race against each other. They race against time, but on dirt, and they fly through the air. People can walk right up to the track, if you want to call it that, and sometimes even sticking their arms out in the middle. So we were using the sensors, these types of sensors, to detect spectators like hiding in the bushes and the tall grass, so that the people running the event could go in there and pull them back to safety. That was one. We did another project with this series called Extreme E that had electric race cars, and we helped them convert those to hydrogen. And even some that were related to autonomous cars, not necessarily racing, but another one where we designed an all-composite autonomous car that had the radar actually in the skin. Anyways, started doing those types of projects. And my last position at Siemens was the VP of Motorsports and Racing Strategy, which really started to bring together all the different divisions of Siemens, from sustainability in buildings to engineering software to energy, and working more closely with a lot of the F1 teams. And now I've gone on getting more back into that startup mode, working with startups and companies in the motorsports and technology industry. So drifted away a little bit into textiles and clothing, but that magnet of motorsports is always there to pull me back.
Yeah, I mean, I think there's quite a few different great things you brought up with that, but and thank you for sharing your background. I think it's always really fascinating how so much of, especially when you kind of get into like carbon fiber and that realm, there's actually a pretty large overlap with the textile world because of how it's manufactured. And it's been a while since I've played around with it, but I actually used to use it quite a bit when either mocking up stuff or even building kind of some lightweight bodies on cars. And it's just a really fascinating technology that a lot of, if you kind of learn more and more about the history, there is a big overlap there because of like the weaving needed to get the carbon fibers just right to make the layups and stuff, and a lot of those technologies. So it's really fascinating to hear that, one, you're involved with that, but then two, I think especially what you're talking about that kind of rapid testing and prototyping needed to really push kind of the limits of these technologies. And that you're right, it's definitely done in aerospace, but it just seems like as far as the speed at which it's done, and also just kind of the not just even the speed, but how the frequency of how it's done in motorsport just still seems to be like second to none. So I think it's so great to see so many of these technologies really be pushed there. And I think we get a lot of questions to that, is motorsport still relevant, especially in this realm of electrification? It seems like it's such a different thing, and how can you really take these technologies that are being tested in that space and like make it so it's something that the average consumer can kind of use? And I know this is kind of an area we want to talk about how these events kind of embrace this and kind of with electrification. But I think I'd just be kind of curious to hear your thoughts at a high level. Anything that you've seen or noticed with electrification and kind of motorsport, as far as like, okay, these are things that motorsport are testing with electrification, and what the end consumer is actually seeing it in products that they can either go buy or having whether it's maybe not the high tier like carbon fiber products they're seeing on the actual cars they buy, but there's learnings from that that are making their ways down to the consumer.
Well, when you think about motorsports, you do think about all these high-tech things like carbon fiber and all that. But I think one thing that you have to remember about motorsports is really an entertainment business.
Yeah.
And if you're in entertainment, your brand, your perception by people is really, really important. And the average age of the racing fan is getting younger and younger, like it is for any other kind of entertainment. So it's really, really important for the motorsports industry to stay relevant to this new generation of fans that are coming in. I was I had a guest on the podcast. His name was Bob Bell. He was the team principal, the leader for the Formula One team that won the championship. It was, I think, 2005 and 6. It was the Renault Formula One team. And I asked Bob Bell, I said, Bob, what's going to happen if Formula One becomes electric in 2030 or beyond? What's going to happen when the roar of the engine goes away, the diehard fan? And Bob said, oh, that's not going to matter. All those guys are going to be dead by then. And so this idea of being relevant to your audience and the audience you want to appeal to, I think forces motorsports to align with those needs. And I think everyone is concerned about sustainability. Everyone is concerned about more efficient use of energy. And so you're seeing in Formula One, for instance, in the 2026 rules, you're going to have a 50-50 engine, which is half electric and half internal combustion. Still 1,000 horsepower, but half of it's going to be electric. Right now, it's about 1585, still around 1,000 horsepower. So you're seeing that. There is this commitment in Formula One to net zero by 2030, and a lot of that has to do with travel logistics and those kind of things, not just the car itself. But of course, I think one of the best examples of electric technology, EV technology, is the Formula E series. And those are all electric vehicles. It's been out there for about 10 years or so, maybe a little over that. And they've done a lot of work in development of different types of technology. I think probably one of the most in things that are related, say, to battery efficiency, that type of thing. So 800 volt systems, battery energy, power management software, those types of things, which have moved in the commercial sector. And in fact, we've got, Nissan, Mercedes, BMW, Renault, Audi, Jaguar, Maserati, Porsche, NIO are all companies that at one time or another have had teams in Formula One. The other thing is they try and keep a focus on sustainability. And for instance, they run their races in cities, not on specifically built racetracks, that type of thing. So that's Formula E. That's EV propulsion in racing. There's a new series, relatively new, within the last 4 or 5 years, which is called Extreme E. Now, that is a really interesting series because, for one, they have no spectators. So I guess you could think of it as an online series. And moving spectators, hundreds of thousands of people, to different cities. There's a lot of greenhouse gases that occur just from doing that. However, so theirs is they stream the events, and they're electric SUVs that race in areas that are challenged by climate change to bring attention to those areas. So, for instance, they may run in an area. They ran in an abandoned coal mine in Scotland. They did a race there. They did races in Sardinia in Italy to bring attention to the wildfires that had been hurting the environment. Senegal, glaciers in Greenland, the rainforests in South America. When they move their equipment, they move it by ship rather than by 747s and that kind of thing. All the cars, all that kind of thing. And they are now even taking that series and transferring the drivetrain from electric. There's going to be a transfer to the power generation to hydrogen. So that's, I think, a really, really, really good example. And the same guy, Alejandro Agag, that started Formula E, started Extreme E, he also started a new series just this year called E1, which is electric boats And being from Boston and a fan of the Patriots, Tom Brady owns one of the teams, and of course won the first race. And I remember speaking with Alejandro. I said, "Oh, you met Tom Brady? How exciting!" He goes, "I've never met anyone that's so competitive as him." But that's an example. I mean, you have people like Tom Brady getting into the sport. It's all electric driven, and even NASCAR. And NASCAR will probably never have an electric drive, at least not for the foreseeable future in their main series. But they have in development right now. And in fact, it's already been tested, an electric version of their car that may run eventually, say, at a feeder series. So it's the traditional role that motorsports has always taken. And I think now it only makes sense for them to do it in this realm of electric vehicles as they've done everywhere else.
No, I completely agree. And I think what is really interesting about the realm of motorsport, especially with electrification, is it does do all of that. And kind of going back to your original comment about being entertainment, it does definitely do that. And it also kind of provides to people watching just the fact that electrification does work. We have electric cars in reality that sure you can buy anything from a Nissan Leaf to like some fully loaded Tesla or Lucid or even electric Porsche now. But this kind of shows that it can also be really fun. It's not just kind of the more average experience, but there's a lot that electrification can really provide with that. I think what you're talking about around, especially like the example of trying to get rid of a lot of the greenhouse gases and stuff like that by looking at other supply chain side of stuff. Because I think what you're talking about is so accurate and spot on is people don't realize, they think about Formula One or a lot of motorsports as just the racing and like building a race car. But the actual logistics between events and getting all of these things between the series are just unbelievably mind-blowing and unto themselves truly impressive, like the efficiency of the logistic teams and trying to get all these things set up in advance and then having it prepped and then having the cars and then actually racing that weekend and hoping that the car itself doesn't break down. And how much, like, people think of like the car breaking down being the big thing, but there's so many things that have to go right before even the race and even the car arriving for these teams to be successful, that is a big challenge into itself to try and get those more not necessarily always electrified, but yeah, kind of go to that conversation around greenhouse gases and try to make it a cleaner and more efficient system. But what I guess one of the other things I'd really like to talk to you about is how we've kind of looked at that, but what going beyond racing and some of the team players in this and how they're embracing kind of electrification in that. What are you seeing as someone who's been in motorsport that really stands out to you, not just in the obviously we talked about logistics, but kind of about the whole infrastructure around it, around charging, around the products that are kind of coming to the market for the consumer. Is there anything that you've seen in your conversations or just kind of indirectly experienced where this is clearly becoming a big thing for them to make these changes and embrace it in a new way?
You know, like I was saying, I think traditionally motorsports has always taken that role to be the leader in development. And, you know, you said something just a few seconds ago that I thought was interesting, is when the Prius came out, and that was a plug-in hybrid, but it was the first realm into the world of electric for many people. And they prided themselves, you know, I'm not sure if everyone's going to agree with this, but they prided themselves in being a very ugly car. And you almost, if you're going to be an electric car, you had to be ugly. And,
for sure.
So that everyone would know.
At best, it looked like a golf cart. Yeah.
Yeah.
Otherwise, it looked like a science experiment.
Everyone had to know that you were a pioneer. You were an early adopter.
Yeah.
But now, if you look, like take the Model S Plaid, the 0 to 60 for Model S Plaid can beat a Formula One car. Now it's not now an electric car with all its weight is not so good on the turns. Right? Yeah, so exactly. You're not going to see a Model S winning an F1 race. But if you were doing a drag race, and I think I've seen some things online. I can't vouch they were 100%. But they did a 911 versus a Model S, I think it was, trailering a 911, and it could still beat the 911 on a quarter mile or whatever it might be. So I do think that the impact on commercial, if you want to call it, or the consumer is probably a better way to put it, is this melding of performance with EVs rather than being a early adopter Prius owner, if you want to call it that. That's really evolved over the last 10 or 12 years. And it's a sign that electric vehicles are coming into the mainstream. I do think, though, that there's a lot of things that motorsports has done in terms of innovation that we really take for granted, and we have forgotten came from motorsports. And I think the first winner of the Indianapolis 500 was the first to use a rearview mirror, so that came from racing. Seat belts, disc brakes, anti-lock brakes, radial tires, and in Formula E, the 800-volt systems, the ability to run at higher voltages, silicon carbide inverters, which are way more efficient. And I think, as I mentioned before, there's some strict rules in Formula E as to how many battery packs you can use, and the ability to manage that battery pack in such a way that you can get the most energy out of it, I think, are things that will immediately work their way, or certainly over time. They've already actually worked their way into the commercial world. Now, they do have some interesting things in Formula E. Some of them they tried and then they took them away. But for a time, there was a chance if you drove over a section of the track, it would actually give you a power boost.
And it kind of gets that entertainment level for sure, where I always thought that was an interesting kind of marketing thing, and I kind of thought it was innovative, and I respected it for what they were doing. But I do understand why a lot of people kind of found it a little too video gamey, and then you could vote. I think this was pretty early on too, where you could vote for certain drivers and whoever had like the highest. Which, I mean, from a marketing kind of social media engagement, I thought was kind of clever and interesting way to do it, to leverage what that could be done. But overall, it may take out some of the reasons that people were actually watching it to begin with, was trying to see a more, I don't want to say even playing field, but seeing kind of the drivers drive, and then also like see what the technology was capable of. And while it got people engaged, it also kind of sometimes maybe gave them an unfair advantage, or just kind of took it out of what the racing's supposed to be. But you're right, like they've changed from like how there were multiple cars, and then they'd swap between the cars, and then how they charge the cars between the races. And it really is interesting to see how that's evolved too, and that they can have these battery packs and charge them like they do.
Well, and again, so you tune in, you see, oh, look at this interesting thing where you can charge the car on the road. I didn't even know you could charge a car on a road. Wow. Right. Is that something that can even be done? And it probably opens up eyes for people as to, oh, well, it's in racing now. When can I drive into my garage and actually charge my car? You know, a friend of mine asked me about, hey, is there any plug-in hybrids that you recommend? And I always thought a plug-in hybrid was really good because it takes away the range anxiety. And most of the time, you never drive more than 30, 40, 50 miles in a day. And most of them can cover that. It'd be nice if they did at least 100 or something. But then I went online to investigate, and I find these articles that say plug-in hybrids will never be popular. And one of the reasons was people hate to have to plug it back in every night to get their 40 miles back. Yeah. And I'm thinking, well, if I had an electric, it's not, because my wife has a Tesla and she plugs hers in, but she doesn't have to plug it in every night. She'll plug it in once, maybe plug it in again in 2 weeks. So the idea of being able just to drive into your garage and the next morning get your 40 miles back without having to get out and plug it in is actually might be an interesting way to get people to drive more on electric drive, even though you've got that in a plug-in hybrid, you've got that internal combustion engine as backup.
Yeah, I mean, I've definitely found, I think personally for me, I either prefer a fully electric or a fully combustion platform, like an electric as a daily driver. Even now there's some fun driving electric vehicles out there too, but then having kind of a combustion for the weekend. And like, for example, I mean, I have a 1987 Land Rover Defender 90 that we used to like go off-roading and do stuff with. And I think last year we put about 4,000 miles on it, but then we put 30,000 miles on our Model Y. And sure, the Land Rover gets like 10 miles per gallon, but I was even trying to figure out like, okay, at 10 miles per gallon, 4,000 miles per year versus the 30,000 we did in the Tesla, even like the MPGe and all these things that are kind of nebulous, but are trying to build these equivalents for people to understand, it still was like such a big improvement over kind of the plug-in hybrid. If we had just had a plug-in hybrid over and tried to charge it electric as much as we could. But what I think so interesting is my experience with plug-in hybrids it's exactly that there's a lot of people who are curious and they may not be ready or may not be living somewhere or have kind of a lifestyle that quite works with having a fully electric where you can charge it overnight or something every time. And it's definitely been a really interesting kind of stepping stone to watch some people I know who have gotten them. Some have had kind of I wouldn't say a bad experience, but they pretty quickly they see people who had a fully electric car and they're like, oh, in retrospect, maybe I didn't feel comfortable or confident doing that, but that is probably what I should have done because charging this thing's kind of annoying because it actually charges slower than my friend's Tesla. And so there's kind of these like weird little interesting things that I never really expected that were kind of idiosyncrasies. Like someone I know got the Volvo plug-in hybrid. They love the Volvo overall, but the issues they've had were some sort of thing with the battery and like the systems talking together, so they had to take into service. And then what was interesting was her husband has a Tesla Model Y. And so when she plugged it in, she expected to get like 11 kilowatts. And even though the battery's so much smaller and it charges at 7 kilowatts, the delta between time to charge up that 40 miles of range versus the full pack of the Tesla turned out to be pretty different. And so it has been really interesting. And I think there's definitely a need for the technology and definitely space for it. But it is kind of fascinating to me. And I think it's something we see with like a lot of the early Chevy Volt owners. They love the Volt, but the vast majority of them pretty quickly realizing like over this past year, I maybe used that combustion engine once or twice. And if it had just been all electric, it would have been fun. And maybe I'd go charge it if I went on a long road trip. But then there's just all these kind of interesting things like in practice, it pretty quickly. And I think so many people just don't like cars and don't like dealing with cars. And pretty quickly, when you realize you don't have to do oil changes anymore, you don't have to do a lot of these other things, that the shift to electrification is actually a pretty big net benefit, assuming you can charge it or have access to like level 2 charging regularly. It's a pretty easy switch. But like you're even saying with the Tesla or a lot of electric vehicles now in that price point and that size, is it ideal to probably always have them plugged in? Sure. But you can go a few days. You can kind of have a setup where it's not plugged in every night and you're not going to be doomed or worrying about it. Versus like if you want to be running on electric with a plug-in hybrid, there's kind of the pros and cons of that.
Well, and you said it too, is that if the number one thing that keeps you from getting an electric car is range anxiety and not knowing if you can plug it in, and having, like for instance, I still race go-karts. I have a go-kart trailer, and I'll tell you what, I have an old Honda pickup that I use to tow that, and I might use it a dozen times per year. And It's not a very expensive truck, and it still runs. But the mileage on that truck is cut in half as soon as I put that trailer on it. And that's exactly what's going to happen to that if I tried to tow it with an electric car. Sure. I wouldn't be able to get to a track that's 200 miles away. But I think in general, if you can afford it, a used internal combustion engine car that you use occasionally for that longer trip is one way to do it. I think another thing too is the plug-in hybrid and the design of the plug-in hybrid. Right now, they're 50, 75. Why not 150 or maybe 200 and make that internal combustion engine smaller? Because when you really need that on the highway, you need it for that long trip. And if you look at the amount of horsepower, in fact, I tried to do some digging on this, is exactly how much horsepower do you need to keep a regular sedan moving? at 55 miles per hour. And it's not very much. Although I couldn't find exact agreement. I'd have to do the calculations on my own or have someone do it.
Well, you're right. Most of the energy is just trying to get it up to speed. And then once you're at speed.
And that's what the electric part is really good at doing with all the torque. Once you get to 55, you might need 50 horsepower, 100 at the most. It's somewhere.
Barely.
So why not a 60 horsepower tiny little motor that you kick in? Now, you're not going to be able to go 90 or 100, but hey, it's a simple motor.
That's kind of the interest we're seeing from a lot of automakers. And this is already kind of happening in China, but what they call the e-rev, where it's essentially a large battery pack. And it's kind of what you're talking about, where it's like 90, maybe 95% of the time, it's pretty much an electric vehicle that is kind of towing around a small little gas generator. But when you're trying to do a long trip or towing, then the small kind of gas generator, I mean, it operates more like a locomotive where it's essentially electric motors doing all the movement, all that power, and then it's only the generator will kind of kick in where necessary to either fill up the battery or kind of make that electricity to power the motors once the battery's completely depleted. And I mean, like even Scout Motors, that was one of the options for their new recently revealed vehicles, was kind of either a fully electric or this kind of battery range extender version, which I think there's definitely a use case for it, especially if you like to do a lot of overlanding off-road trips into really remote places. It's a pretty nice feature to have. And I think there's definitely a market for it. And it wouldn't surprise me if we start seeing again where people, just as battery ranges and stuff increase longer term. But yeah, I think it's totally a good use case for people who tow a lot or go into really remote places. And then when they don't need to, and it's still a huge delta as far as like what is emissions and how much they're using gas and all this stuff. And so it kind of gets things kind of going in the right direction anyway. And I think for a lot of these people, the advantage too is then instead of it being kind of a plug-in hybrid setup where it can be kind of actually a little more complicated and you need a really advanced sometimes transmission and all these things, it's still just electric motors. All you're doing is electricity generation. So you still actually have far less parts. You have a much better, I think, driving experience and a much more linear acceleration, all these things that are kind of great about EVs. And then, yeah, you get the range. And then if you're towing, you get all that torque and stuff. And you fill up after 400 miles, which really isn't much different, if not even better, than a lot of large pickups when you're towing.
Well, and I think you've hit it, right? This whole idea of the range extender. And you mentioned the Scout. And if you go way back, well, somewhat way back to the BMW i3, which was one of the first electric cars out, that was pretty much an electric car. And then they'd say, oh, there's a little range extender in here. I forget the size of the range extender. It was like 800 cc. It was a tiny little motor. Now, that car, getting back to composites, was an all composite body, which looking back is a little bit crazy. I mean, who's going to make an economy car out of the most expensive material in the world? So that didn't make any sense. I always like to say, because that was still in the days when we were working on composite software, but I like to say that BMW learned what not to do with the i3 when making an economy car. I mean, carbon fiber is good.
Whenever anyone asks me for a recommendation for an around town electric car, that's usually one of my first recommendations, is just to get one of those used. They're pretty fun.
They're a good price now.
Yeah. Oh yeah. They're good price. They're incredibly safe. The amount of ratings and what that thing can get into from an accident standpoint for being essentially a small city car and be a much safer vehicle than even much larger vehicles. I think it's an awesome vehicle. And you're totally right. It was one of the best examples of R&D of a large automotive company going kind of wild and thinking, oh, this will eventually kind of pencil out for us. And maybe it will, but unlikely. And it just seems like the timing was definitely way off for them as a company to try and figure out how to put that in there. But it's just been, I think those are just fun, great they're funky looking. And they're the epitome of a car designed by an engineer versus something that's sexy and aesthetic. But it's a very impressive vehicle. And if you don't really care about the aesthetics and you just want a small little easy driving city car, they are phenomenal.
Well, you mentioned safety and the carbon fiber. So carbon fiber and the carbon fiber monocoque got into Formula One in the 80s, in early 80s. By the end of the 80s, pretty much everyone had carbon fiber monocoques. And if you look, Formula One started in 1950. So you got the 50s, the 60s, and the 70s. And throughout those decades, roughly each decade, about 15 people, 13 to 15 people, race car drivers actually lost their lives driving in Formula One. And then in the 70s through the early 80s were the years where the horsepower went crazy. The cars back then had horsepower to weight ratios that are almost 50 to double what they are now. And as a result, safety became more and more important. And the carbon fiber monocoque, if you've seen some of the crashes that they have in Formula One, and you see carbon fiber going all over the place, and they just walk out. And the reason for that is if you look at a crash structure, it's made out of steel or of aluminum. It's basically a crash beam that would crumple. And as it crumples, it absorbs energy. With carbon fiber, you've got, like in the monocoque, there's dozens and dozens of layers, hundreds of little pieces of carbon fiber that are in effect held together by epoxy. And to tear those layers apart requires so much energy that all the energy gets used up and the driver on the inside stays safe. And that's why your i3, even though it's a little teeny car, is probably one of the safest cars to drive in. So another thing that I guess eventually, if we can figure out how to make carbon fiber a little bit less expensive, you would see it working its way down into more lower price consumer vehicles.
Well, and I think it was really interesting because it seemed like BMW was trying to do that, because then you start seeing like their not their iPhone, but like their 5 Series and 7 Series, and they kind of mention, oh, we did this thing, and it's made out of carbon fiber, and it makes it stronger, and it saves 20 pounds. And it was just really interesting, where it's like clearly them as a company were trying to figure out how to best leverage all this money that they've spent building a really interesting, cool product. But how do they get it to a point where they can scale it? And now you kind of just seen that even go away, unfortunately. It's a hard challenge to figure out, to kind of find those critical weight savings that justifies that price delta.
And they spent billions and billions, and they had a factory, it had automation. And the one thing with carbon fiber is the more complex curvature you have, more complex shapes you have, the harder it is to make them without manual. Formula One cars are made manually by hand. There is no automation. There is automation in aircraft, like the Boeing 787. Is robotically made, the entire, but that's the fuselage. But it's a nice flat. It's a tube. There is no tubes in Formula One, or even in an i3. There's cars, just by their nature, they're small, they're compact. There's a lot of curvature there. Look at the shape of the passenger cell of an i3 versus a Boeing 787. And it's probably one of the greatest challenges ever to do that cost effectively. And but anyways, they gave it a try, and it at least shows the power of carbon fiber, and again, some of the technology for motorsports and how it can affect the commercial world.
Oh, for sure. And I'm kind of curious, like, the lessons learned from that and what we're seeing now with BMW kind of going into electrification. It does seem to be that they've taken a pretty big step back from that. They spent a lot of money, obviously. And it's interesting that, to me, so many cars now are so heavy, electric or not, or even hybridized, how heavy a lot of cars have gotten. And now with electrification coming on, we are starting to see EVs lighter than their gas. I mean, I forget what like the new BMW M3 starts at, but it's like it weighs more than a Model 3, which is a fully electric. And there's little nuances, sure, but like for what has traditionally been like the performance light go fast vehicle in that sedan space. And you're seeing this not just with BMW, that's just one that kind of stands out, I think, got a lot of attention, but a pretty big step away from lightness. And yeah, some of that you could say is due to safety and other kind of regulations that have kind of added complication. But I'm curious to like, and almost kind of surprised that we haven't seen more, speaking of like innovation in motorsport, like leveraging design that tries to minimize weight And of course, a big part of that is the battery causing that weight difference. And we're starting to see improvements there. But like, this is kind of the realm where I've been surprised with a lot of the legacy auto manufacturers of not seeing more innovation around weight savings, or like how to better use these learnings to create more, I wouldn't say necessarily more competitive product, but it'll definitely make the product more efficient and kind of give them that less, then you use less batteries and you get more range out of it.
Well, I think in racing, when it comes to the car body itself, and there you can afford to use carbon fiber. You're not so much worried about the labor and all that.
Yeah.
But a lot of these innovations that are more subtle, and I think weight reduction is one of those. You don't really see weight reduction. And
yeah,
let's go back to the i3. When the i3 was coming out in the 2000s, the whole automotive industry said, "Oh my God, everything's going to become carbon fiber. We got to do carbon fiber." And then suddenly steel. Oh my God, steel. We got to get rid of that. That's for sure too heavy.
Yeah.
It's carbon fiber versus aluminum. All right. So now aluminum and carbon fiber are battling it out. And when BMW went from the i3 and eventually to the 6 Series, I think it was, and the 7 Series, for a while they're calling it carbon core, but really had only like 4 or 5% carbon fiber. Right. Yeah, and the 6 Series had no carbon fiber. In the meantime, aluminum's getting better. But then, and now if you look at the materials that are in cars, especially at the lower end, steel has come back. And what they've done is, the steel business is a big business. They're not just going to sit back. And they went from just having mild steel to press hardened steel, to advanced high strength steel, super advanced. And some of those steels are more expensive, but they start to approach the stiffness to weight and strength to weight ratio of aluminum. And now certainly in the lower cost cars, because steel is way more cost effective than aluminum. Forget carbon fiber; it's never going to be in a car under $30,000. But steel is working its way back in, and but you don't notice that, I think, and that's what makes possible some of these. That helps reduce the cost of an electric car, because if you're going to put that big heavy battery in there, first of all, the batteries are just heavy, so you got to move them around, make it as light as possible. But the other problem you've taken that battery and you've put it at the bottom of the car, and now you got to still make that car stiff. And so you got to make that battery pack, you can't have all that dead weight in there. It has to contribute to the strength and stiffness of the car. And you have to protect the battery at the same time. So innovative designs that are more lightweight but still give you strength and stiffness. And I think Tesla has had some patents in this area where they use aluminum casting as a single piece for the whole car body, and the battery pack is an integral part of it. These are the things you never see when you buy a car, but they are happening. They are happening. There's always a drive for weight, but you have to do it in a cost-effective way, and that's the real challenge.
Well, and I know, there's a lot of reasons and benefits for that. Obviously, some of it's range, but also the lighter it gets, and this is one of the things I know we wanted to talk about, was just kind of the reductions of energy being used. And so like metrics for greenhouse gases and those being used in racing. We've kind of mentioned a little bit about like hydrogen, but I know this was kind of a topic you wanted to talk a little bit about. So I'm curious to kind of hear your thoughts about this in general in this space, and what you kind of see as the future, maybe in the next couple of years, and then maybe what the next decade looks like. Because there's been a lot of talk of what some of these new technologies are and how soon or to what scale they can be implemented.
Well, just going back to some of the time I spent at Siemens when I was the head of their motorsports strategy. Siemens used to be big into sponsoring Formula One in the 2000s. McLaren, I think it was in the mid 2000s, but now completely gotten away from it because, in part, because of sustainability and the bad rap that motorsports has gotten. And motorsports has realized this, and within the last 5, 6, 7 years, they've decided they have to do something about the reputation that motorsports has, because like we spoke about earlier, that's really, really important for them to maintain the Formula One or what any kind of racing series brand is. And so what you have to do is, before you can improve your sustainability, you have to understand what your sustainability is. What are the emissions that you have now? Where are they coming from? And there's this group called Lab of Thought that did a comparison now. Now that Formula One has been working on their net zero by 2030 program for a while now, and they've taken the measurements they've made of their emissions and they compared it to cycling. So cycling would be Tour de France, Giro Italia. In Spain has a thing called Volta. And so they looked at the entire series of cycling versus a Formula One annual racing series and all the events they do. And if you look at the emissions that they had, cycling was 7 times greater in CO2 emissions than the entire Formula One series. Now, if you look at the actual event itself, the cars, they are less than 1% of the total emissions that you get from the Formula One series. But the car does emit more greenhouse gases than a cyclist does. So that's for sure. But it's a teeny little slice. The majority of that comes from, and I think it's close to 75% comes from moving people and teams and broadcasting equipment, moving all the equipment that the cars need to do the pit stops in the garages and media centers, whatever it is. That's like 75% of the emissions. And if you look at cycling, sure, the bicycles are great, but they've got chase vehicles and they're moving these events all over the place. And I think that's where you end up getting this increase in the 7x increase for cycling. Now, I think the most significant thing about all this is motorsports has to change their reputation. And the only way to do that is, one, and the FIA, the sanctioning body's taking the lead on this, is they've gone in and they've done a very thorough job in measuring where they are right now and what their emissions are. When the Lab of Thought did this comparison to cycling, only the Tour de France had actually measured what their emissions were. So they had to estimate what the other ones are. And I think that shows the commitment that motorsports has in this area. And I think for instance, I mentioned 50% electric drive in the new rules that come out in 26 for Formula One. 100% renewable fuels, e-fuels. Now these would be carbon neutral fuels, would be used by the year 2026. So pretty much all their major series would be using that. So a lot of big steps, I think, are being taken there. And again, even thinking about things like Extreme E, that's running events in areas that are challenged by climate change. And if you do go to the events, they actually there will have, and even on their broadcast, they'll have climate scientists come in and give talks about what's going on in that area. And so they're using, the profits and really they're seeing it's very important to take the resources they have and use it as a platform in this area of sustainability. So again, you got to sort of peel the onion away a little bit, right? And look underneath to see what's really going on. But I think that motorsports is definitely stepping up there. And now it's time for cycling to do the same.
No, I think that's a great comparison. And, you're not the first one I've heard say that, but that is like something that probably a lot of people don't think about or fully realize that would be the difference in those two. You did mention e-fuels, and I'm kind of curious for your thoughts on that, because there's been a lot of talk about e-fuels in general for the past decade at least, maybe longer. And I think recently it does seem like motorsport's been kind of the one talking about it again, and it seems like it makes a lot of sense for that space to kind of keep going with the combustion side of stuff. But it also seems like it's going to be way more expensive than traditional gas, which, I mean, racing gas, even of the non-e-fuel type, is always usually more expensive than this stuff. And so I'm kind of curious on your thoughts about, do you see kind of e-fuels? I think it's totally fine if they're really just in motorsport, and in the scheme of what motorsport pays for and deals with, your fuel prices going up a little bit really isn't that big of an expense compared to building the actual car and all these other things. But do you see e-fuels having much of a chance at scale beyond? Because it seems like we hear that one is just the increased cost of what it takes to make it and kind of how to do this ethically. but then it just also sounds like it's unlikely to ever be something that gets at scale to bring the cost down significantly enough to be something beyond motorsport, which personally, I totally get that. And I'm okay with it just being a motorsport thing. I think it's kind of great to see that go and then embrace it, at least in that way. But I'm just kind of curious on your thoughts about that or anything you've heard or what that might look like.
I think you raise a good point. Well, it's hard to predict the future. So,
For sure. Yeah.
what's going to be in 10 or 15 years? I
Right.
mean, when I think the first Formula One race in 1950 had drum brakes, which fade. It's all sorts of
yeah.
And within a year or two, this is the 50s. Now they had disc brakes. Oh, who needs those in cars? And they're expensive. I mean, they're
Right.
hard to make. And next thing you know, they're used because the cost came down when you're producing in mass, and they are safer, and especially in wet conditions and things like that. So e-fuels. Well, first of all, you got to look at them in two ways. One is, what are they really doing in terms of carbon emissions? And I think also the cost. And Porsche built a plant in Chile, and what they did was you have to first, you got to create hydrogen, and you do that with electrolysis. Electrolysis is not cheap when it comes to the amount of electricity it needs to take all that hydrogen out of the water. And so they put a bunch of wind turbines on the mountains of Chile, and they were able to make green electrolysis, I guess you could call it, that then was combined with CO2 that was scrubbed out of the atmosphere. And now you've got a carbon neutral fuel. I think there might have been methanol in the middle of the process, but eventually you had a carbon neutral fuel. And in fact, at that point, it's carbon positive. You've taken the CO2 out. Then what Porsche wanted to do, and what they're doing is, then they'll take this fuel, and then if they have these things called Porsche Experience Centers, where for those that can afford it, can go drive a very expensive Porsche. And now you can do that and actually be carbon neutral, because you've taken carbon out of the air in Chile, and you're probably redepositing it at Silverstone in the UK or something like that. But it truly is, it is carbon neutral, but it very, very expensive. It's very, very expensive.
Right. Well, and I think even you actually did a really good job of describing the process, but I think anyone listening to that process can kind of understand that there's so many steps to get through that it's like, how can you, in what world could you do that in a cost-effective way? But I think it is also really cool and impressive that obviously that's such a big thing at Porsche, and they are an innovator in a lot of ways. And I think it's really cool to see them go that far along the process to really try and make it work. And they have. But yeah, as we're kind of talking about it, just to do that at scale and the price, I don't know if that makes sense, but I think there's argument to be made that it's really cool to see that. And like I said, when you start getting into that realm of motorsport, whether it be at scale for like entertainment, like a Formula One, or for personal, gas price, okay, it went up a little bit. In the scheme of like going through race tires and all this stuff, it's not that big of a delta of what you're spending anyway. That if we see more and more of kind of private and large scale racing go that way, I don't think it's going to be as heartfelt as like maybe the average person going to the pump. And I think that's kind of cool to see that is an option for people to stay in the space. And I think there will be, I know it seems premature to use it as an antidote, but a lot of people compare like what the future of motorsport would be like to horse racing, where it's like, yeah, people still have horses, but it's a very expensive, very small niche endeavor. I don't know if it's going to be that small, at least not anytime soon, but it is kind of a way to kind of fill that gap and also make it, I think, check a lot of the boxes that people that have been concerned about the space can now actually say that, yeah, in that example perfectly, that it is actually not carbon negative, I guess, with everything that's being done
for a while, right? And then eventually, well, though, you raise again another good point, which there's a saying in motorsports is, if you want to make $1 million, then start with 2, and then you'll end up with 1. So very few people that are engaged in motorsports. I mean, we see Formula One and IndyCar and NASCAR, and those people, many of them, not all of them, are making money.
Yeah.
But there's that's just the tip of the iceberg. There's so many people that just race for fun or race semi-professionally, and they are spending a lot of money to just enjoy the sport. And then it's like horse racing, right? If you want to win the Kentucky Derby, you're spending a lot of money getting those horses to where they can do that. And the same goes for a race car. But in the end, which has really been somewhat of a theme of what we've been talking about here, it's motivated Porsche with their high-speed experience centers to at least look at e-fuels. Now, I think at a minimum, it jumpstarts us towards knowing if e-fuels if they're ever going to make it or not. Just like BMW learned what not to do on the i3 when it comes to making an all-composite fighter plane, commuter car, right, with the same construction as a fighter plane. I think you'll probably start to learn, you know what, it's never going to go under $50 a gallon or 25 or whatever the number is now. Maybe it will.
It's cheaper than I thought it would be. I'd have to look it up again. But while you were talking about it, I did Google it quickly, and it went live in 2022. And I don't remember the specific per gallon price, but I believe it's like $8 a gallon.
Oh, really? Well, that's not too bad.
I could be wrong. But I think that's what I'd heard last, and I was trying to confirm that. But even at $8 a gallon, it's not cheap. But
what's gas in California?
Compared to like a set of Michelin tires and all these other things, it's like, and like you go to a lot of racetracks now that have fees and all this stuff, and good or bad, it's just like everything else, it's gotten more expensive. But it's not like buying uranium expensive. It's not like $100 a gallon. But and maybe I'm incorrect, but I believe last I heard it was like $8 to $10 a gallon, which is still crazy, but for a lot of things isn't that far. I mean, like you can go buy gas for boats at a lot of places, and they'll charge you like $6 a gallon just because they're the only place you can buy the gas from.
See,
same with like aviation gas.
Porsche e-fuel costs. Trying to see. I thought it was more than that. You can edit some of this out, right?
Oh wait. Yeah. You're correct. Okay, so I did find this.
Roughly $2 per liter.
Well, this looks like a pretty credible source, and I'll try and get a link to it in today's show notes. But it says Porsche will first use e-fuels in special products, including, and this was I think from last year. It currently costs $45 per gallon to make, and this was from June 20th of 2023. But it is projected to cost less than $8 per gallon by 2026. So
there you go.
Not a steal, but it's coming
$8
down.
per gallon is not bad, right? Gas is what is it, $5 or $6 in California?
Yeah. Who knows? Maybe e-fuels in California would be $10.
Going from 30 to 8, you don't do that overnight.
Oh, for sure. And a lot of that is scale, but like I said, is that what everyone at the pump can afford? Probably not, but it makes it being a pretty realistic option for a lot of tracks to even offer, if they can do it to that level, just because, like I said, aviation gas or even gas you get for boats isn't far off that. It's just that they charge a premium because they have it in such supply, or they're the only places you can get it from. So it's like, if it's around $8 to $10 longer term, I think it definitely doesn't, by no means it's like a deal breaker for the sport or people who want, like you said, want to do it personally or professionally.
Well, one thing to think about is to say, okay, I'll give you two challenges. You pick one and you have to invest in it. Challenge one, bring the price from $8 down to $4. I'll give you 10 years. Or two, build an infrastructure to charge every electric car in the entire world in 10 years. Now, because you got your infrastructure already for the e-fuels. If you put it that way, that's an interesting proposition.
Yeah, and I think it is kind of, there's interesting points to both those sides, because you could kind of say the thing about electric cars is like, well, you can charge it in a 120 volt outlet today. Is that realistic? And can you do that scale? Probably not. But it's not to the same scale like you have to have DC fast chargers like you do gas. But you're right that it is still something that has to be done. Even if you decide you just want to put in more level 2 chargers, that's still a large infrastructure change. I guess what's really interesting is the difference is, do you invest in the fuel source, or do you invest in the infrastructure to support the fuel source? So electricity we kind of have, and we can generate more ish. It's just like actually getting it into the car through, whether that be at home or in your own the charging station itself. Whereas with this, we have the fueling infrastructure. We've had a century really to build that out. We just now have to make this new crazy new clean fuel, which we now at least have a model of how to do it. It's how do we do it larger, so it's just a scale problem for either. It's just where that investment goes.
And figuring it out is the tricky part, because
having
it's
a
not
map is easy.
it's not black and white.
Yeah,
I mean, you don't have to say, oh, we're just doing e-fuels, or we're just going to have this infrastructure cut and put our money there. Maybe it's a combination of the two. Is, wow, if we invested X amount, we'll take the 100% we're going to put in infrastructure and give 20% to e-fuels. That'll hold us over till 2035. And by then we'll have the infrastructure there, and then it'll be cheaper to go that way. But I think in our society now, there tends to be this black and white type of thing. And it's hard to do things in between.
Yeah. You're right. And doing a collective mixed approach versus one or the other, you're totally right. And I think it's been fascinating, because even to see the one approach, you don't have to go too far, unfortunately, to see like there's been a lot of money spent, and then what's going to come out on the other side has kind of been hit or miss depending on where that source of money is coming from. But I think will that change? For sure. It's just a really fascinating. They're both technologies we more or less had in theory for over a century. One's electric and motors, and the other's gas and combustion engines, are over a century old both. It's just at what evolutions on the fueling infrastructure side are we on that have had that century of focus, and what needs to change. And I do agree with you. I don't think it to me, it seems likely long term that the vast majority will go electric. But I also don't think, I think it's also really silly to a lot of people like, oh, we don't need oil and gas. They're like, well, yeah, you do. There's the plastics put in these cars are oil and gas. The oil that's in the motor itself, it's going to change to what scale and where these products are coming from. But it doesn't mean that you're going to get rid of it completely. And there's still going to be a place for aviation fuel. There's still going to be a place for jet fuel, and now it looks like e-fuels. And I really don't think it's a one or the other. I think you have to be smart at where you're putting the focus. And I think there is a place for hydrogen in all of this, but I think for a lot of light duty stuff, it seems pretty clear that will go electric. And then it's kind of these other use cases, TBD, but there's good arguments for these other fuel sources and technologies powering them.
Well, shipping, I think, is a great example, because in shipping, if you were going to make an electric cargo ship, just think of how much cargo is going to become those batteries that you're hauling around. So there's where an e-fuel would be a much better application than a car on the street.
Totally. From like a carbon, like from a emission standpoint, shipping is terrible. There's no argument there. I think there's an argument maybe to be made that there's some sort of hybrid solution, and then you've got these ideas that people are trying to go back to being wind powered in sails. I don't know if that's going to happen. I think it's an ambitious idea, but no, you're totally right. Where it's like, well, if we go to a cleaner fuel source today, we see a pretty immediate impact, and if there's battery technology or hydrogen or whatever technology down the road, great. But there's a fuel source that's being so heavily dependent on, that's having such a large outsized impact in that one industry. Why not do that? And I think that's actually, for all the talk green hydrogen gets, like heavy industry makes a lot of sense for it to go like manufacturing and like steel and aluminum smelters. That I could see going hydrogen powered, just because you have these large facilities that can have large areas for storing hydrogen and then use it in a effective way. I don't think it's going to be in cars. I don't even know if it's going to be in trucks. But like heavy industry, yeah, hydrogen makes a lot of sense. E-fuels in racing and shipping, I could see that, because they are carbon intensive, but also effective in just getting the stuff there. It's like, how do you change what the out product is? And then electrification for light duty, unless you're towing and you're towing more than a couple hundred miles, especially if you're like a small city or these other things, there's a lot of truck things that can be done within cities that the price of the products need to come down. But long term, I don't see why they wouldn't go electric.
Well, I think one way to look at this is is it hydrogen, or is it an e-fuel, or is it a battery, or some combination of those that creates the power? You have to deliver the power to the road, to the tires that are moving the thing forward. And that's where I think electric drive is far superior. And if it weren't for the fact that electric motors have gotten more efficient, they've gotten smaller, the power to weight ratio on those has gone way up. It's possible with four-wheel motors that you can brake, you can do traction control, you can accelerate the car. So a computer and four-wheel motors. Now, where's the power coming from? Well, maybe it's coming from a pure battery pack that you charge, or maybe it's got that range extender on, or maybe it's a little internal combustion engine that's running on an e-fuel. I mean, hydrogen is a lot of, it's inevitable. Cars are going to be electric drive. I mean, it's so sweet. I mentioned my wife has that Tesla. Hey, no oil changes. The brake pads will probably going to last longer than the rest of the car.
Right.
And you don't use the brakes.
Yeah, it's no brake pads, and like that is one of the biggest reasons I loved going electric was just no oil changes. And I know that sounds like a silly thing, but as someone who drives a lot, and I've done my own oil changes, that I enjoy it, but some of the places I lived, it wasn't really easy to do that. And then going to spend 80 to even $100 to get oil change, I was like, okay, now this really sucks. I'm wasting time to go somewhere to get this done, and I'm spending so much money to have someone else do something that's fairly simple. And I think you're totally right with like the e-rev scenario, that if you're towing, or like I said, anything light duty, I just don't see how it doesn't go to it's electrified, and then maybe there's a range extender if it's a case that needs towing or something. But just the torque. And I think it's one thing to talk about like motorsport and performance vehicles, but when you look at the vast majority of people, they just need a thing that gets them from point A to point B. And an electric car seems like a sports car to them, even if it's a large, heavy thing, just because of the power delivery and it being just continuous instead of having kind of the clunky. I think that's been my biggest issue with so many plug-in or hybrids, and let alone plug-in hybrids. They drive terrible. And it's not like, maybe there's like some of the higher, like the Volvo and the Mercedes ones we were talking about, they handle fine, but it's just like the gear, like having like 9 gears and it takes 4 years just to get to 50. It's that kind of thing that I think most people, when they experience just that kind of linear speed, they don't really know the difference, and it's a much better experience to them. And I think sooner or later, a lot of these light duty things will just go that way, just because that's what people get used to and kind of expect it to feel like.
Well, in the end, and I think Stellantis announced this recently, that they're going to be testing, I think, a limited size fleet with their solid state batteries. And it was and so they say 600-mile range. Now it's not going to be commercially available, but they are testing it on the street. So does that mean in 5 years you're going to be able to have a solid state battery that will get you to 600, or in 10 years it gets you to 1,000? You charge or 2,000 and you charge your car.
I think
four times a year or something. I don't know.
I've kind of worked in the solar industry in kind of like the mid to early 2000s, and the big word then was nanotechnology. And I feel like in the EV space, especially with batteries, that is kind of now like the buzzword is like, oh, just solid state. That's kind of this magic amorphous thing that'll solve everything. And I think it has a place to play, but I think realistically what's going to happen is we're not going to get cars with 800-mile batteries. We're going to get the same cars with much smaller batteries that go 300 to 400 miles that last longer and charge faster, even though I think everyone has this idea in their mind. It's like, oh, I'm going to go 2,000 miles. In the end, right or wrong, the manufacturers see this as a way to get less batteries into more cars versus putting a bunch of batteries into a few cars. I mean, I think there may be like some high-end, it wouldn't surprise me if like the high-end Ram TRX or something, maybe it has like a 600.
Well, that's how it always goes, right? You start up there. but
Right,
solid
that's true
state
too.
battery.
That's a good point. Yeah, that kind of
There-
starts and then kind of works down.
Solid state, saltwater batteries, sulfur batteries. I even read about a battery that's made from lobster shells, crustacean batteries. So I mean, I think the point is everyone's trying to figure out
Yeah,
the super duper
exactly.
battery. Hey, is it going to be solid state or this or that? The thing is, there's so much investment being put in there because we know we need batteries, and some of them are going to be applicable for that big factory that's making steel, and others might be for our home, and some can go in cars, and it'll
Yeah.
make that electric drive. The electric drive is the way to go. I mean, it's just so simple. They'll put all the car maintenance people out of business. You can't go from 10,000 parts to 4 or 5, right? And
Right.
on the drivetrain and not make it more reliable.
Exactly. And Ed, I just want to say thank you. I realize we've kind of gone over time, and it seems like we could probably keep talking about just motorsports in general, let alone the electrification of it. So for anyone that's kind of listening to today's episode, what's the best way to get a hold of you or kind of learn more about the Future Cars podcast and the other things you're working on right now?
The best way would be on LinkedIn.
Great. We'll have links to that and all of your content in today's show notes. But Ed, thanks again for coming on, and definitely want to talk to you soon. And I know with just how quickly electrification is happening, especially in motorsport and some of these cool things. I mean, we didn't even get to talk about, like, speaking of hybrids, I think the coolest hybrid that's come out all year is the new Porsche. Like, you leveraging it to kind of get rid of turbo lag, I think is a great example of what you can kind of do with it. But that's a whole nother thing. We didn't even get to that. So Ed, thank you so much for coming on today, and looking forward to speaking with you again soon.
Yeah, we'll have to do the performance EV as the next one. I think
Exactly.
we could talk for hours and hours on that one, I'm sure.
Yeah. Thanks so much, Ed.
Thank you, Chase. Enjoyed it.
Thanks for tuning into this episode of Grid Connections. We hope you enjoyed our conversation with Ed Bernardon on the future of motorsports, electric vehicles, and sustainable technology. Ed's insights into how motorsports are paving the way for innovation in electric vehicles, battery tech, and sustainable fuels offer a powerful look at what's next for the industry and for all of us as consumers. If you found this conversation as fascinating as we did, please share with someone who would enjoy it too. And if you have a moment, leave us a positive review on our podcast page. Your feedback helps us bring more conversations like this to an even larger audience. Thanks for listening, and until next week, this is the Grid Connections podcast signing off.